All right, so we're going to start off with some stuff that we didn't cover last week in PCB design. I wanted to talk about condensing the size of the board, and then also about what we want to call design guidelines based on the PCB house that you're going to actually send this to be created at. So one of the first things is, you kind of saw, hopefully you guys saw our little Roger and I back and forth about trying to get a smaller and smaller version of the circuit board to make it as small as possible. So one of the things we didn't cover last week was that when you have multiple inductors that are going to be in a circuit, you actually want to, every other inductor, you want them to be at a 90-degree angle so that they don't interfere with each other. And so what I've done here, if I turn off the back silk screen, let's see, we'll turn all the back stuff off here so you guys can kind of see it. Well, actually, no, I'll just go to the View 3D. Hold on. And then, so what we've done is we've actually placed these inductors at 90 degrees, and that way they don't interfere with each other, or the interference is as little as possible. The other thing that I did was try to scrunch everything together to make it, to make the board as small as possible across. And if we flip it over, we've only got a few points where we're going to actually be soldering. But that was the first thing. The other thing is the distance between the left jack and the right jack actually needs to be properly spaced so that it will fit in the breadboard. So we're looking at the headers on the breadboard are spaced out at 2.5 millimeters apart. So what we want to do is we want to make sure that the dead center of this pin and the dead center of this pin are actually spaced on a 2.5 millimeter center. So if we go back over here, we can actually check that by going over here to inspect and use the measure tool. So what I did was grab the center of this pin, and then I drag it over here, and I grab the center of this pin. And so it's 43.18 millimeters. So if we go down here and we grab Mr. Calculator, we put in 43.18 and divide it by 2.5 mils. I'll now get 17.2. It moved it on me. So we're going to have to move this in a little bit because we want it to be really at 43 mils.
So Jim, the one on the left, it looks like it isn't on the center of the pin, or is that just the way it is?
I think it's just on the
other end.
Oh, well, you know what? Let's go pin to pin. So let me click the center of this pin. Let's drag it to the center of that pin. It's still off by 0.180, right?
Okay.
So let's. What we'll do is let me go back over here, and we're going to get a very, very small grid, 0.005. And I'm going to click this guy. I'm going to move him ever so tightly, or just a little bit, and then let's measure it again. He wants to do that here. We probably need to move him one more time, so let me do that. Okay. Oh. I'm just using my arrow keys because my grid is now set to 0.1270 millimeters. If I click this and I pick M, I can actually move it left or right by that increment. And then when you're done, you just hit enter and that'll stop moving it. We'll go back over here and we'll try it again. It doesn't look like it moved at all, does it?
No, it's still the same number.
Yep. So let's go pick this guy, move. And inspect, measure.
Oh, now you're just under.
All right, so we're going to have to go to a smaller size to move it now. So let's I guess we'll go a 1/2 mil. It's going to be fun. I'll move it 3 and then we'll try it again. $4,926. So
Hey Jim, I don't want to throw a monkey wrench, but you should measure center to center of the pins where you want it on your breadboard, and because it spreads a double bus, as wide as this board is, there's no way you can get it like on either side of a bus, so it has to straddle a bus.
right.
You also leave some area outside the edge of the board to connect other wires. See what I'm getting at?
Yeah.
So if you go 43, I think that doesn't leave any area. You're going 43 pin to pin because of the edge.
Well, why don't we go in and?
Well, I'm just saying, yeah, the whole board needs to go into about 30. The whole width of the board needs to probably be about 37. About 37 to be able to have a couple of pins on each side of it to put other wires.
That should put it on a 2.5 mil center, and then we'll do the same way with this other one.
Right, but I'm saying then you got to bring the edge of the boards in real close to that so that.
Yeah. No, I agree with you. Let's see, it's too far. Okay.
I guess you could always put your jumpers on first on the outside rows, like on row A and I'm sorry, row F and row E to the right of the bus. Put your jumpers on first, and then put your board down. It would cover your jumpers, but that's one possible way to do it too.
That's 38.1. So let's see what 38.1 is.
Yeah. Well, hopefully the boards are similar, but 30.
That's 15 spaces.
Well, because it spreads that double bus,
Right.
it straddles that double bus. It's not an even number of spaces. You just have to measure if you're going to put it across the bus. You see what I'm saying? They're evenly spaced within a particular board, but the way those breadboards are made, that double bus in the middle there,
Right.
it doesn't come out even. That's what I'm saying.
Yeah, well, that's actually what I'm trying to do is actually move some stuff out of the way so that I can get overhead view so we can actually talk about it on the board here. So
Yeah.
um,
37 is a good number.
so one more mill down.
If you can get it.
I
I don't remember.
probably could.
Go look at mine. I don't remember if I made that or not. Then that gives you another mill or two for the edge of the board, and at least one pin on the outside of the board that you put jumpers on.
Let's see. So what we're talking about is we're going to have to span this place here.
Yours different than mine. Mine's got two. That's probably the problem. Then yours has a single bus in between the. Mine has a double bus in between it, so it's just a different board.
Yeah. But if I was to count, see, because this one here, I guess you can't really count that as 5. That's only like 4, right?
Well, yeah, it's not. If you take your calipers and measure across that bus, it won't. I don't think it'll come out to an even number. It might, but
Yeah.
So.
No, because I think it's built in as part of this piece here, right? It's solid here, and then that's 1, and then it just replicates itself again.
I guess these boards aren't built to an industry standard, because mine each bus is a separate little strip that can be clipped in and out and that kind of thing. So
yeah, what I need to get is I need to get a. Let me see if I can't find a. I'm grabbing trying to find one of my rulers so that we can measure it.
I'm going to share my screen so you can see what you got.
Okay, let me stop sharing here. No, X. Oh, okay, go ahead.
Yeah, you got it disabled.
Oh, do I again?
Yeah.
No, I don't.
There
Zoom
we go.
does.
Now it's going to do it. Let's see, where's my camera is the next question.
See, 30. So 40 mils would actually put it right between 2, because here's the 0 line here and here's 40. But that's the pin placing, and like what you're talking about, if we go a couple more mils beyond that, then you're gonna basically run into. So we really want to keep our width of our length of our board like 45 mils at the most.
Mm-hmm. So I guess not all breadboards are created equal. There's no probably industry standard or anything. See how this has double buses?
Yep. Yeah, I see.
And each one of these is a separate little vertical strip, That's a strip. That's a strip. That's a strip. There's another strip there.
Yeah, see, mine's actually it's just missing the double bus. So it's a little bit different. Yeah.
Yeah, I'll kind of flex it. You can kind of see end on
Hello.
where the strips are.
Okay, I'm gonna go back to sharing my screen again. So what I was gonna say is at 38, right? And I guess I can, let me zoom in a little bit more, because I don't know if you guys can see that clearly or not. But if at 38, that kind of hits us like here to here. You almost need to be 37 mils, right?
37 would be good enough.
Yeah, and that would give you plenty of room, at least for the pin to pin. But then what we need to do is we have to pull everything down a little bit, right? Or move these guys up. So let me switch back over here to the desktop. So we would have to take and move these guys. Bring them up and over like that, possibly.
You already bring that big old huge thing.
I got it turned down. Why isn't it? Okay. Let's try that.
Did you get it ordered?
No, I don't know. I think I might have shut him off. That's good.
There we go. So that's one of the things we got to play with, right? Is we've got to be able to get that at like 37 mils, the pins. Or, well, actually 38 if you go center to center. So let's see if we can't get it down a little bit more. Oh.
Now, it's a shame these aren't sticky traces. You know, they don't go with the
I know.
part when you move it. That was kind of disappointing. Every time you move something, you got to redo all your grid
Yeah.
and everything.
Well, so at 38.1, that will fit. You may have to force it a little, to bend the pins a little bit. You guys are all seeing my screen, right?
Yes.
Yes.
Okay. I just wanted to make sure. All right. So now we got to go back and we got to redo the traces. So let's delete that guy. Delete that guy. Because I'm also going to bring everything else in as well and try to make the board itself smaller. And all I'm doing is I'm just clicking on it till it highlights it. I'm hitting the delete key. If you're wondering what craziness I'm doing. Okay, so let's hit our wire. Start at that
Is there
point.
any issue on the boards, on RF boards, about square corners versus chamfer corners like you have below C8 there?
I don't know of any issues. And when you're talking about is whether they're whether it's straight square or, I don't think so. A lot of people will just go 45 out and then make your, but I don't think there's really an issue. Let me,
Well, I think the reason for the 45 trace is like the one from C7 to L3 is just distance. But I'm just saying, as far as corners go, like a sharp corner versus a chamfer corner like you have down by C8 or the one by C10. Is there anybody know about any differences regarding those?
I do not. The biggest thing is just trying to get it, a lot of it is, it's basically using your grid, right, to create your trace.
Mm-hmm.
And that's because like here, we could have went with a chamfer here as well, right? Because I've seen both. And I don't know of any issues. I know professional drafts or professional designers probably do have a reason, or were taught a reason why they do it a certain way. I just don't know what it would be, because I haven't. Again, I'm an amateur.
Well,
So-
I'm looking at a professionally designed board, filter board, and there are no square corners on it. All the traces, every trace has a chamfered corner. I mean, they're almost to the point of being rounded. You know, they're chamfered as much as they could, kind of like your one right there by C1. So I don't know if it matters or not.
Do that. I gotta redo that last one. I really think it has a lot to do with the way they lay out the board, right? So now let's take and let's bring in our ground plane. And then we'll bring in our cutout.
I don't know if it's by design or what, but it may be serendipitous, but the distance for the 4-pin header that we chose,
Yeah,
from pin 1 to pin 4, matches up with the PC board BNC type fittings.
oh, does it? That was not intended.
Yeah, you'd have to put another one about where the radio is on I Love Radio thing there, where the center conductor goes. But the other, about right there, yeah, you'd have to
Yeah.
put one between those two, and it would match up with that.
That's cool.
You could put BNCs on it. I haven't tried it with SMA yet. But.
Well, let's run the design rule check again and see if I missed anything after we did all that moving. Okay.
It looks like you've got a couple of your traces on the back side or something like that.
Oh, you know what? Yeah, you're right. This trace here looks like it's on the back side.
Yeah, and the one over on J2 as well.
Okay. And we want that to be on front. So let me select this. Well, let me go back. It was actually on the, I think on the back silk screen.
Roger, the answer to your question is in meeting chat from Chat AI.
Okay, I was just getting to that. Sorry.
And what does it say, Scott?
45-degree corner refers to, well, blah, blah, blah. Okay, refers to. Corner looks like the L shape. The design helps to reduce the likelihood of signal reflections and impedance mismatches at the corners as it maintains a relatively smooth transition for the signal. You skip down into the second part. It said the choice between a 45-degree corner and a chamfered corner typically depends on specific requirements of the PCB design. For high frequency signals or critical applications, the 45-degree corner is often preferred to maintain signal integrity. However, in less sensitive designs where dealing with mechanical considerations, chamfered corners might be used for improved durability and aesthetics.
Yeah, the reason I was asking because I know it matters at microwave frequencies. I'm not sure it matters at these frequencies, but I was asking if anybody knew, definitively where their chamfer corners were better than square corners. I know in mimic design and microwave stuff that we used to do, you actually create capacitances and inductances based on, it's all straight line or teed traces, and it does, create a reflection back at mimic frequencies. So.
Right. Now let's see how our design.
I would think
checks
it
turn
wouldn't
out.
matter at these frequencies, but
Yeah, I didn't know, so I went and looked that up.
yeah. Well, I appreciate you looking that up because I intuitively I think it doesn't, but I just doesn't hurt to mirror it any way you can, I guess. So.
No, it's not that. Where is my ground that it says it's unconnected?
I get that every time. It's not unconnected. I just don't understand why it gives me that warning. I get that same warning all the time.
Yeah. Well, what it is there's probably an older track that's sitting here someplace.
Oh, you need to redo your screen. That's what
There
it
it
is.
is. See it?
Yeah, that's it.
Yeah.
You need to redo your screen too, the ground plane.
Polygon on silk screen. I'm not going to worry about that. Silk screen clip by solder mask. I'm not going to worry
Not the
about
silk
that.
screen, the ground plane.
Okay, so I've got a question. Couldn't you run
Yes.
some of these traces on the other side of the board if you needed to as well for room?
Yeah.
Probably costs more.
Oh, hold on. I gotta find Steve. He came out and he stuck out of the room. There we go. Welcome back, Steve. You missed a very enlightening discussion on 45-degree turns versus 90-degree turns. And we came up with that it actually is done to reduce, what was it again, Scott? Signal
Reflection.
Design style helps to reduce likelihood of signal reflections and impedance mismatches at the corners. It's in the meeting text chat if you want to read. I skipped the number one and the number two and went directly for the question Roger had asked.
Oh man, I just did this again. Back copper. No, I don't want to go that way. It's going to be a pain in the butt. Okay, so, and you were saying about redrawing the screen?
The ground plane. Just
Oh,
erase
yeah.
it. When you do the if you just delete the existing ground plane and then redo the check, it'll put it back in.
Oh, okay. Get back over here. So you say if I hit delete?
Yeah, and just redo your check now. It should put it back in.
Nope.
Well, oh, did you delete the whole thing or just the actual?
Let me rerun it.
Well, you also lost a trace there. You got one
Yeah.
trace.
So is that trace not wanting to draw because it actually sees that L2 is there?
No, what it is my grid spacing. Let me make my grid spacing smaller. Now it should do what I want.
I think the outside track isn't a bad way to go. I don't know.
The outside, oh, going out and around.
Yeah.
I don't know. It's the OCD in me about wanting things to, if one side goes in and up, then the other one should go
Right.
in and up.
I try to
right?
make them symmetric, but just so there's no issue about one balance on the board and stuff. But I'm just
Yeah.
saying, instead of running it under the inductor, it might be better to go out.
Okay, so now let's look at the size of the board, right? So what I'm going to do, our board is going to be 43.815 mils by 19.6. So we're basically 44 by 20 mils. So we're about 1 3/4 inches by just under an inch. So we'll save that. And then we'll go back over and we'll go view it and see if it looks pretty, or do we need to move something else around? That looks okay. Let's flip it. We don't have any interference with anything. I know it keeps complaining about the solder mask on the screen print, but I don't think that really matters. And then I think the other one was on C3. It's saying he's sitting on that, so we could move that over a little bit. So let's take C3 and see if we can't move him just. Nope. Move him just a little bit. Probably not going to get much, but we'll run the design rule check again and see. It's close enough. All right, so let's talk about submitting this to a PCB factory. I'm going to use JCL PCB because they seem to have some of the faster turnaround times, but there are several other ones. There's PCB Way. I mean, if you go out and look, they've got all sort of different ones. This also, if you're doing something that's within 100 millimeters by 100 millimeters, it's going to cost you like $2 to get 5 boards. Is going to be your base price. So what one of the things I wanted to kind of talk about is depending on what your what we're actually generating, they do have instructions in here on, if you go over here to PCB file preparation, and let me come on, I want to go to no. They do have a whole bunch of FAQs on how to do it, from like, you know, how to generate from Easy EDA, you know, how to do it for KiCad 5 for Autodesk Eagle. So you can usually go out here to their help center and find instructions on how to do it. And that's actually where I got this one. KiCad 6, that's the latest they have. So we'll go ahead, and what we're going to have to send is what they call the Gerber files. And that's going to define your front and back copper layer. Matter of fact, if we go back over here to KiCad, it's going to be your front and back copper layers, your front and back paste layers, your front and back silk screen layers, your mask, and then your edge cutouts. So that it has everything to know in order to basically create the PC board and know how big to make it, you know, how much copper to etch away and everything. So the way we design these is we're going to go over here to File and Fabrication Outputs, and we'll click on Gerbers. Let me okay, can you guys see the Gerber plot?
No, we just see the menu.
Okay.
We can see the plot window. Yes.
Okay. I just want to make sure. Am I sharing? Okay, I am. Okay. Okay, so in here, what we're going to do, if we go back over to generate, we're going to be looking for these layers. Front copper, paste, and silk and mask, and back copper, paste, silk, and mask, and then edge cuts. So if I come back, there we go. So we got front and back copper, front and back paste, front and back silk screen, front and back mask, and then edge cuts. But there are also some settings that they want you to also make sure that you have set up, because they take things a certain way. So if we go back over here and look, they're going to want to make sure that we have plot reference designators. Check the zone fills before plotting. Use Protel file name exemptions. Extract the solder mask from the silk screen. And then they don't care whether you use extended format or not, or use extended X2 format. So we'll go back over here. We'll make sure that we've got plot reference designators, the checked zones. Use Protile and subtract solder mask from screen. So what we'll do now is we'll go ahead and we'll click plot. And what that did is that saved it out to a directory underneath here under session 6 schematics called Gerber's. And once we're done with that, then we have to, the next step is to go through and generate the drill files. So, and they have some specific about, use alternate drill mode, make sure it's absolute for the drill origin. We're using millimeters and decimal format. So let's go over here and let's click generate drill files. Bring it back over here so you can see it.
We don't have any oval holes, do we?
No, we don't. But what I've found is if they say to use that, use it, because there may be something that comes up and that you don't realize that you actually have oval holes. But no, everything we have should be all circles, right? So so we'll go ahead and set it for use. That map file format is Gerber, drill origin is absolute, millimeters, and then decimal format. And then we'll call, and then again, we want to make sure our output folder is in the same folder of where we put our Gerber file. So we'll call generate drill file. And then when it's done, they suggest that you go ahead and generate a map file. And then when we're done with that, we can go ahead and close this out and close that out. So now if I go back over here and we go into Gerber's, you'll see we have session 6, the back copper, the back mask, the paste, the silk screen. We have our edge cuts. We have our front copper, our mask, our paste, the silk screen. And then we have our drill and our drill map and another drill file and another drill map. So what we're going to do, and let me just shift delete this. I'm going to go ahead and I'm going to just basically compress that zip folder and name it low pass filter board V1 or 1.1-0. Okay, so now we've got the file that we can upload. And if we go back over here to, we can go ahead and we can go add that Gerber file and click open. And what he's going to do is it's going to go ahead and read it in and look at all the files, and it's going to process them all. Make sure that they're good. So this is what our file looks like. You can actually go out here and look at the Gerber Viewer and actually look at the file. Oh, okay. And so you can look at the different things. You can like turn off different pieces if you want to. You know, there's turn off the solder mask. So you can just double check, does it look like what I expect it to look like? You can look at the bottom layer. That's what the bottom layer looks like. You can look at it in 3D and flip it around. Funny how our top layer disappeared. Okay, so what we're going to do then is we're going to go in here and we're going to start picking stuff. You could pick different, like you could do a flex PC board. You could do aluminum, you could do copper core, Teflon. We're just going to stick with standard FR4. It's a 2-layer board. It picked that up automatically. We'll come back to PCB quantity here in a minute, but and a product type is this just industrial consumer electronics. If you're doing medical or aerospace, they actually will do more processing on it. And this is one design, and it's a single PC board. And we'll just go ahead and leave it with the 1.6. Now, if you wanted to do a different PCB color, like you wanted a blue one or a red one, you could pick that out. Say your silk screen is going to be white. You could pick your copper weight. You could set up whether you have tinted or untinted vias. The other thing we're going to want to do, though, when we do this, is we're also going to want to get a stencil. And the reason we want to get a stencil is because it'll make it much easier for us to apply solder paste on all the SMD pads so that we can take and run a layer across it and then place our components and then take it and sand it. So we'll go ahead and we'll say, yeah, we want a stencil. Now, what I was thinking is in this order, so that everybody has something to build, I was going to basically order 40 boards. That would be 10 sets of 4 boards each. So you'd have the ability to do like a 10, a 15, 20, and a 40 bandpass filter. So if I go out here and say, hey, I want, well, I can get 50. So my cost is $17 for 50 of these boards. And then because they ship via DHL, it's going to cost $31. To get, you could always go with, express economy, 3 to 5 business days. I'm actually going to go ahead and order it with Express Worldwide because I want these to be here before the 15th of August, right? So that we have them available. So I'm going to go ahead, I'm going to save it to the cart. And then let's go view our cart. So what we have is we have our stencil for it and we have our filter board. We'll go ahead and I'll go to secure checkout. Oh, great. You guys all know where I live now.
I want to see your credit card.
I'll probably pay via PayPal.
I'm ready with the screenshot.
Yeah. And go via PayPal. Okay.
We owe you 45 a piece, right?
45 a piece. Well, 50. They're $1 a piece. So yeah, $4. But now that's basically been submitted, and we just got to now wait for them to come back and say that they've actually put it into production. I'm going to go ahead and close this down. Now they do have, if you do want to look at your files before you upload them and just double check, there is this trace space.io or trace space, and you can actually upload a Gerber file or your whole zip. So like I could throw this up here, and then we can actually like, that's the top, what the top's going to look like. This is what the bottom is supposed to look like. You could also go to layers and you can turn off and only view the ones that you want to look at. So let's say we just want to look at the bottom copper. That's what the bottom copper would look like. If we wanted to look at the top copper, we can look at how the top copper is laid out. And then we could throw on our solder mask. And then here's our silk screen for the top. And then here's our solder paste, which should actually match right on top of our solder mask, right? So if I turn this off, you see it does match like where we're going to actually have stuff here, but because they're SMD components, they line up right on top of it. They don't cover these other ones because those are all through hole components.
Does the screen match, edge match? Is that how we register it?
Yeah, actually, no. What you get is a full sheet. It's I think the size of it. If I go back over to PCB Way, let me go back to my here, and if I remember, this stencil is actually 380 by 280, so it's like an 8 by 10 sheet of metal. So we would have to cut it down in order to do edge match on it. That's what kind of threw me off the first time I ordered a stencil. Is I got this thing that looked like it was a photograph mailer, and when I pulled it out, it was basically two hard pieces of cardboard with the stencil in the middle. But yeah, we could go and cut it down if we wanted to. I think this one was the same way. It was 380 by 280. So it basically, you get your top and bottom on the same stencil. So you're going to have to kind of lay it up, line it up, and then basically tape it down.